Hello, ladies and gentlemen. Welcome to the final Semester 1 SAT Math lesson of the calendar year. We'll see you again in January, so it's not like you won't see any of me or won't hear my voice anymore. This week's topic, we're going to do some more additional work with point slope and slope intercept form of a line. Please make sure that your name is legibly written on the name line so I can figure out who your paper belongs to. And make sure you've circled both your teacher's name and what class you are in. If you're in more than one class and have more than one teacher, feel free to circle more than one. Now, folks, before we begin today, I want to remind you that during this video, your job is to pay attention to the video and take notes on the front side of this worksheet. These examples are here so that I can warn you about the things on the SAT, the pitfalls, the tricks, the language that they're going to use. If you're not paying attention, if you just flip the paper over and do the back side of the paper, chances are good that you're going to make the mistakes that I'm trying to warn you about. During the video, your job is to take notes on the front side of the paper. So here we go. We're going to start with example 1. Example 1 says, which of the following could be the equation of a line that passes through the point 4, -1 and has a slope of -2. So when we do a problem involving a linear function, we need to ask ourselves whether that problem is asking us to use point slope form or slope intercept form. And it comes down to what information did they give us. They gave us a point and a slope, which means we should be using point slope form. Y minus y1 equals m times x minus x1. When we look at this, the point 4, -1, that's your x1 and your y1, and you're given a slope of -2. So we're going to plug that information into our equation. So y minus -1 equals -2 times x minus 4. Y minus y1 equals m times the quantity x minus x1. Now our answers are all in slope-intercept form. So next, we are going to convert into slope-intercept by solving for y. Okay. So that would involve distributing the -2 and getting rid of this double negative here, which would give us y plus 1 equals -2x plus 8. And then we would subtract 1 from each side. And that would give us our answer in slope-intercept form, y equals -2x plus 7. Y equals -2x plus 7, or D, is the equation of the line that passes through that point with that slope. Okay, example 2 says in 2005, 120 students at Lincoln High School had smartphones. By 2010, 345 students in the same school had smartphones. Which of the following best describes the annual average rate of change in the number of smartphones students had from 2005 to 2010 at Lincoln High School? Rate of change is a word that should, as a phrase should jump off the page at you. It should absolutely jump off at you because that is a fancy word for slope, which means we are probably supposed to be finding slope. And in fact, we do have 2 points. We have in 2005, 120 students had smartphones. And in 2010, 345 students had smartphones. So those are your 2 points. We have the point 2005, 120, and the point 2010, 345. So these are your x1, y1, x2, y2 for your slope formula. So we plug those in. Y2 is 345 minus y1, which is 120, over x2, which is 2010, minus x1, which is 2005. And then we're going to simplify that. So 345 minus 120 would be our first step. So 345 minus 120 is 225. And then 2010 minus 2005 is 5. So what that's saying is there was an increase of 225 smartphones over that 5-year period. Now, we don't care about over the 5-year period. We care about the annual average, which would be per 1 year. So we need to actually divide 225 divided by 5, and that tells us that the slope is 45 phones per year. So when we look at our options, there's the 45. The average increase in the number of smartphones per year is 45 phones per 1 year. Okay, on to example 3. Okay, which of the following is the equation of a line which passes through the points -4, 2 and 4, -4? Now, in order to find the slope of in order to find the equation of a line, we need to know two things: slope and a point. Right now we have 2 points. So step 1 in this process is to find the slope. And we're going to use our slope formula, which is not on the SAT reference sheet. So it's an equation that we need to know. y2 minus y1 over x2 minus x1. Again, that's x1, y1, x2, y2. And there is an alternative way to do this involving putting these 2 points into a table and looking at it as the change in x and the change in y, and setting up the slope as change in y over change in x, which is fine. You can do it that way if you prefer. Okay, either way, you're going to get the same slope. Okay, so we plug these numbers in: -4 minus 2 over 4 minus -4, and we get -6 over 8, which is, by the way, the same thing we get if we use the table approach, which reduces to -3/4 to be our slope. Okay, so the same thing over here. We would get -3/4 when we reduce the fraction. Now, once we have the slope, you'll notice all 4 answers to this problem are in point slope form. Now, right away, when we get a slope of -3/4, that eliminates answers A and B from possibly being correct, because in both of those problems, the slope is listed as -4/3. So from there, it looks like we need to use point slope form, which again is something that is not on your reference sheet. So you need to know that point slope form is y minus y1 equals m times x minus x1. Now, there are 2 possibilities here, because you could also plug in the other point. You could plug in y2 and x2, and you'd get an answer as well. So one of those 2 points is going to provide you with the correct answer. So if we plug in x1 and y1, we would be looking at y minus 2 equals -3/4 times x minus -4, which would be y minus 2 equals -3/4 times the quantity x plus 4. And if we plugged in x2, y2, we would have y plus 4 equals -3/4. That didn't come out quite right. Let me fix that so it's not confusing. -3/4 times x minus 4. So one of these 2 is going to be the correct answer. Well, if we look at our options here, we don't have a y plus 4 possibility. So we're not using this version here. This is not the version we're using. We're actually going with the x1, y1 version of the equation, which is choice C. All right, so that's just once again us going over point slope form and slope intercept form. Remember that they are connected to each other. Point slope, slope intercept, slope formula, even standard form, which is where you graph using cover-up method, they're all over the SAT, guys. You've got to be fluent in linear functions. So On the back are several examples. Once again, you know the drill. Turn your paper over and try those on your own. Again, hopefully you filled out the front and can use the front to help you correctly answer the questions on the back. Thank you very much for your time and attention.